Okay, I see a lot of you working on your papers that are due tomorrow. That is your classifying reactions, which also includes balancing. And for our evaluation tomorrow, all you're doing is balancing chemical reactions, okay? They could be reactions similar to what you see up here, okay? So I just put some examples up there. If you want to go over them, we can do that if you feel very comfortable. These are fairly complex reactions. If you want to go over them, we can. Otherwise, I'm not going to stand up here and waste your time. I guarantee you it. Okay? No. No. Not the same exact questions. No. You all have a very good understanding of this. And again, this is just balancing tomorrow. And we wouldn't expect you to classify these, although the top and the bottom one you probably could classify because they're just opposites of each other. Okay? Yes? Okay? So then, if you had to classify this, what would it appear to you? Yes, top one is a synthesis reaction. Then what is the opposite of a synthesis reaction? No. Decomposition, that's right. So in this case, you see two substances combining to form, you could, whether you say this is more complex, it has everything involved in it, even though phosphorus is in two separate spots. Okay? This one you have it being broken apart into three distinct pieces, or three distinct compounds, if you want to look at it in that manner. Okay? So, when we go over these, how many of you still write the number of atoms underneath here? And that's fine. There's nothing wrong with doing it that way. Some of you just like to do trial and error and just do the math in your head. That works too. Okay? So I will give you a few more moments to write this down and maybe make your way through these, and we will come back in about 4 minutes. Okay, we'll go ahead and proceed with these. And for those of you who do, or how do I want to say this? Take the approach that just do trial and error. Sometimes that works the best. So with this, we would say maybe start with your metals if you don't know where to start. Okay? So how many calcium atoms are on the reactant side?
3.
How many are on the product side?
1.
Okay? So let's just give it a try. Okay? So once you do that, that has to be distributed through the entire compound now. So your calciums are now balanced. So with our trial and error, okay, inside the parentheses with this phosphorus gives you how many?
6.
Just inside the parentheses.
2. 4.
Inside the parentheses.
2.
Inside the parentheses.
1.
Inside the parentheses.
4.
Okay. When this gets distributed, just to this point, inside the parentheses, 3. All right? Now you go outside the parentheses. You have how many?
6.
Now you've got 6. Okay? So your calciums are balanced. Let's look at our phosphorus then. Okay? So we've got how many phosphorus from this compound?
2.
Inside, but then distribute that. I need to do a better job maybe saying how to go about this. Inside the parentheses, there's 1. You distribute it, then you get 2. And then how many phosphorus are here?
3.
Okay? So notice you have 3 on that side and 6 over here. Well, you might want to double it, but you would want to be careful, because if you double it here, what does that do to your calciums on that side? Then you have to change it. Now you'd have to put a 6 here, but we don't know if that's going to. Yeah, you certainly need more hydrogen because, okay, 3 times this 2 is 6. 6 times 2. Okay, so we got 12 hydrogens. How many hydrogens are this side? So how many would we need? Okay, so again, it's just trial and error. Okay, then let's distribute this 3 to our oxygens here. 3 times 4, 12. 12 times 2, 24. Okay, so let's look at what we have so far. We've got 2 phosphorus. And then 4 times 1, 4 plus 2 gives you what?
6.
Gives you 6. How many phosphorus are over here? 6. Okay, let's look at our last remaining element, which is oxygen. 2 times 4 gives you 8. 4 times 4, 24. So let's look at our oxygens over here. 3 times, we did that already. 3 times 4 times 2, 24. I don't know. I just put an equal sign just to show that our oxygens are now equal. So 1, 4, and 3. Okay. So let's go ahead and proceed on to our next one. So if we're just looking at trial and error for these, where would you want to start? Just trial and error.
Start with AL.
Okay, let's try our aluminums, see once what happens. We have 2 aluminums on this side. How many are over here? There is? There's 1 right now. Let's just try putting a 2 there once. Okay? Your aluminums are now balanced. Okay? But this has to be distributed through. How many nitrogens do we have? Okay? How many nitrogens are on this side? So why is that little 2 there? Okay, so what other elements are diatomic? Oxygen, hydrogen, chlorine, bromine, iodine, and fluorine. Okay, so what about our carbons now? We've got 1 on each side, right?
Yeah, but you need to get your oxygen.
Okay, because we've got 3 oxygens over here, and how many are on this side?
1. So you need to put 3.
Let's try it. Now your oxygens are balanced. Now let's go ahead, and you've got 3 carbons on that side. Now what about here? You need to put a 3. Okay? So, in the blanks, oops, I did that wrong. I had the right idea, but I just put it in the wrong spot.
1, 3, 1, 2.
1, 3, 1, 2, and 3. Okay? Now, for the most part, we would say keep your polyatomic ions together if you can. But that's a problem with this compound, or this reaction, because we've got ammonium on our reactant side, but we don't have any ammonium on our product side. So therefore, again, just by trial and error, okay, there are 2 spots that I could think of that you may want to look at first. either your nitrogens or your fluorines. But nitrogen we said first. How many nitrogens are over here? How many nitrogens are over here? So what do we need to do here? Okay? Then let's just see once where the math leads us. Okay? Your nitrogens are balanced. Now let's look at your hydrogens. Okay? How many hydrogens is this? 8. Okay? And we've got 7 over here. So it doesn't mean that we're wrong. Okay? It just might mean let's look at another element to balance. Okay? You've got, we can't do beryllium because that's a 1-to-1. Okay? We can do our fluorines because how many are here? And how many are over here? Okay? So if we did this, is that going to help? No, it's not. Okay? But remember, we had said that we've got 8 hydrogens on this side. 2 times 3 gives you what? And then if we needed one more, what could we put here? By trial and error. Just try that. Are your hydrogens now balanced? Yes. What about your fluorines now? We've got 2 here, and distribute that 2 to that one, gives you 4, and we've got 4 here. So that would have to be right. So we've got 1, 1, 2, 2. Okay? Do you feel comfortable with just balancing only tomorrow? Okay. Do you want to go over more examples? I'm going to leave that up to you. Okay. So you have about 20, a little under 20, a little over 20 minutes. Go ahead and utilize this time. Classifying the reaction paper is due tomorrow. And then your first evaluation, which is just balancing only, is tomorrow. I had a question of how many there were. I said 4, maybe 5. We have a pretty good understanding. 4, 5, or 6. We'll see once how that rolls out tomorrow. We'll catch up to you next time.